well. So, introduction to real numbers. Let's start it from the next page. The name of the chapter is Real Numbers. What are real numbers? First of all, we have to understand this. So, in the very first point of real numbers, it is given that real numbers are union of both rational and irrational numbers. All the real numbers are the union of rational and irrational numbers. If I say in simple language, then if we collect all the rational and irrational numbers, then all of them are real numbers, or if we want to simplify it further, then any rational number. They can be called real numbers and irrational numbers can also be called real numbers. Even if we combine both of them, they will still be real numbers. This is given in the next point. These numbers can be expressed on a number line. All the real numbers can be expressed on the number line. Like this, we have a number line. On it there is 0. Apart from that, on this side there is 1, 2, 3, 4. On this side there are -1 to 1, 2 to 3 numbers. These can be represented, can be shown on the number line. All of them are real numbers. Apart from this, it is given here that these numbers can be both positive and negative. All of them can be positive as well as negative. That is, they can be in minus and can also be in plus. I have explained both the things here. Now I will give some examples. Like here, these numbers which you can see are from real numbers. Here there are some rational numbers. Like we can have any number between 1 and 2 because it is given to us in the form. Like here it can be March 2nd. This will be our rational number, and if this can be shown on this number line, which can be done, then this will also be our real number. Whatever rational numbers there will be on this number line, all of them will be real numbers, and whatever rational numbers there will be. Like root of 3, root of 5. These are our numbers like our pi. Whatever numbers of this kind there are which can be shown on the number line, all of them can be represented as real numbers. Here we have understood what real numbers are. We have taken some examples here as well. So after real numbers, now let's go to the next page to understand what comes first in this chapter. After understanding real numbers, the next concept in the chapter is fundamental theorem of arithmetic. Let's understand what this theorem tells us. So it is given in this that every composite number can be written as a product of prime numbers in one and only one way. Fundamental theorem tells us that any composite number, if given, the composite number can be written in the form of product of prime numbers. If I give you an example, you will be able to understand it better. Like here we have two composite numbers. One is 60 and one is 420. Whatever these composite numbers are, these numbers can be written in the form of product of prime numbers. Prime number. It can be written in the form of its multiplication. I will tell you in writing it. Then it will become like here whatever we have 66 and 420. How will we write them in the form of product of prime? Here I have written 66 for it. We have to do prime factors. So here we will do it with 2 times 3 is equal to 6, and again 2 times 3 is equal to 6. Then here we will do it with 3 times 1 is equal to 3 times 1 is equal to 3. Then here we will do it with 11 times 1 is equal to 11, whatever our number 66 was. This 66 is a composite number. This number we can write as the product of prime numbers. You are our prime number. 3 is our prime number, 11 is also our prime number. We can write 66 in the form of multiplication of prime numbers. 1e. Product. Like this. We can also write 420 in the same way. This also needs to be written here. Let us factorize 420. We have written 420. We will do it with 210. Then again with 20, then it will go to 105. Then with 3, then it will go to 35 times. Then if we do it with 5 here, it is 7 times. Then with 7, it is 1 times. Whatever our 420 is, we can write it in the form of product of prime numbers like this. What will come first? 2 by 3 by 5 asterisk 7. Whatever our two composite numbers were 66. We wrote it in the form of product of prime numbers like this. And whatever our second number was 420. We also wrote it in the form of product of prime numbers like this. It tells us fundamental theorem of arithmetic that any composite number can be written in the form of multiplication of prime numbers i.e. product. Now what will be the advantage of this? Whenever we find the prime factors of any number, these are called prime factors. If we find the prime factors of a composite number, then it helps us in finding HCF and LCM. Now after finding the prime factors, let us also understand how to find HCF and LCM. So here is given HCF and LCM using prime factorization. Here we have done this prime factorization of 66 and 420. With their help, how will we find HCF and LCM? Look here. First of all, let us talk about LCM. Whose LCM are we finding? Of these two numbers 66 and 400. Whenever we find the LCM or HCF, then first of all we will need its prime factors, which we have already done here. Now after finding the LCM, what do we have to do? If we have to find the LCM, then what do we have to do? Here, first of all, our prime number which will be the smallest. Here what is 2, so we have to see where 2 has appeared the maximum number of times. Look in the one above. In the 66 it has appeared only once, but in 420, you are there. It has appeared 2 times. Where we have to pick it up. Here 2 has come multiplied. So we have to pick it up and keep it here. Simply 2 and multiply 2. So 1 came here, we sent this 2 by 2 here. After this next we have to see which number is bigger than 3. Look here. There is 3. It has come once in the upper one. It has come only once in the lower one. It has come once in both. So pick any one above or below. It has come once. So it will be written here only once. After this, see which number is bigger than 3. There is 11 here. There is 5. There is 7. So we will give 5 first. 5 has come only once. 5 has not come above. It has come only once. So we will multiply 5 here and then in the multiply. A number bigger than 5. 7 has come here. There is no 7 above it. 7 has come only once. So it will go here. After that in the multiply. Here is the number which is bigger than the 7 is 11. So we will write 11 here as well. What do we have to do here? It is very simple. Wherever it is greater we have to pick it up and multiply it here. Like you were alone. We have to leave it. Wherever 2 times 2 is greater, we have to pick it up and place it here. Now when we multiply them, we will get our answer which will be the LCM of 60 and 420. It is very simple to multiply u by u. It will become 4. For 4 will be multiplied by 3 will become 12. 12 will be multiplied by 5. It will become 60. If we multiply 60 by 7, it will become 400. If we multiply 420 by 11, we will get the LCM. 4620. We did prime factors in a very simple way. After that, we get the LCM of any two numbers here. This will be a simple method to find LCM. Similarly, let's talk about HCF. In HCF, we have to find from which number we have been given. We have to do prime factors of them. After doing prime factors, we have to see what is common between both the prime factors of the upper and the lower number. Now we have to find the common here. That is, the one which comes in 66 as well as in the prime factors of 420. So look here. 10 has come in this. 10 has come in this as well. What is the common here? 10 has come here as well. 10 has come in both. So we will take the common here once and write 10. After that, put the multiplication sign. What is common above and below apart from 2? Like 3 has come here. There is 3 below. There is absolutely 3 here. 3 has come in this as well. 3 has come in this as well. So we will write 3 here once. Apart from 3. Look here. There is 11 above. It has come but for 420. If it does not come in the factors, then it will not be written. Similarly, here 5 has come but 5 is not on top. So this also will not be written. 7 has come in this. It does not come in the factors of 66. So 7 will also not be written. The HCF of these two numbers 66 and 420 will be 2 by 3. 1e. In the method of finding the LCM of 6, what we have to do is that we have to take the number which is given the most number of times and all the numbers will come, but in HCF only common numbers will come. So the fundamental theorem of arithmetic tells us that a composite number can be written in the form of the product of prime numbers. After that, whatever prime factors are there, they help us in finding the HCF and LCM. We have understood everything here with examples. Now the next concept of this chapter is for that. Let us move to the next page. The next concept in the chapter is the relation between LCM and HCF. We have understood how to find LCM and HCF by prime factorization method on the previous page. Now understand what is the relation between LCM and HCF. What is the relation between these two on this page? So whatever is the relation between LCM and HCF, it defines a formula. The formula is written here in front of you. First number multiplied by second number equals 2. LCM multiplied by HCF. If we are given any two numbers, then we have to find their LCM and HCF. If we want to do it, then we have to use this formula. This formula defines the relation between their LCM and HCF. For example, if we take an example of it here, it will become absolutely clear to you. Take whatever is our first number. It is 66. The second number given to us is 420, and we are also given the HCF. 6 will be the first number 66. Again, the second number 420. HCF is given to us. 6. We are told to find the LCM. This is the relation between LCM and HCF. How to use this formula? Take whatever is our first number. It is 66. Number second number LCM and HCF are total number of factors. If any three of these factors are given and fourth factor, we can find the result from it. By using the formula, we can find it very easily. Let's suppose we don't know the first number. Well, we have to find the first number. We are given the second number's LCM and HCF. So we just have to put the values in this formula to solve it. Then we get the first number. Like here in the example, we have been given three things. First number, second number, and HCF. We have to find the LCM. So we have to put the values in justice and solve it. Then we can find the LCM easily. Whatever our first number, second number, and HCF are here, we put their values. What we have to do first is we have to put the first number, whose value is 66. After that, we have to multiply it by the second number which has been given to us. For 20, so here it will go 420. After that, put the equal sign here. HCF will be there in LCM multiply. So we have to find the LCM. We do not know the value of LCM. So the LCM will be like this. By applying the sign of multiplication, here we will find the value of HCF. 6, so here will go 6. Look here, we know the first number. We know the second number. We know the HCF. We have to find LCM. So it is very easy to find the LCM. 66 by 420, it will go equal to you. The LCM will be 6 in the LCM. The multiplication here is 6. If we shift the 6 to this side, here in the multiplication, on shifting it to this side, it will become 6. Now whatever 6 is below here, 66 is above. 66 can be cancelled by 6. 616 can be cancelled by 6 by 11 times. Now whatever value is there, let us calculate it. In the multiplication of 11, there is 420. If we multiply 11 by 420, then it will become 4,620 equals. Then our LCM will go ahead and it will become this. We know the first number, second number and HCF. We put the value in it. So whatever was the value of LCM, we get that. So whatever is the formula of relation between LCM and HCF. It is very important. Questions related to it always come in the exam. So remember this. Whatever is the relation. I have defined that formula for you and you can also see the examples related to it. I have explained it to you. So the concept of relation between LCM and HCF is complete. Now the last concept of this chapter is a saving. For that, let's move to the next page. The last concept of real numbers comes in which we have to prove that a number is irrational, like here is the proof root. You are irrational. We would have been given some numbers like this: square root 2, square root 3, square root 5, square root 7, square root 11. We would have to prove that some such numbers are rational. And one method for this is the contradiction method, in which we do exactly the opposite. We have to prove that it is irrational. But we prove that whichever number is given is not rational. If that number is not rational, then it will become irrational in itself. Like here. What is root u? An irrational number? We have to prove it. But we will prove that this number is not rational. If this number is not rational, then it will become irrational in itself. It is a very simple method. That is why it is called contradiction. Instead of calling it irrational, we prove that it is not rational. So, in the proof also, in the beginning itself we will take the assumption that whatever number we have, it has been given that this is a rational number. So for that I will write here, let us say that the root of our number is a rational number and rational numbers are in the form of p/k, in the form of a/v, in the form of fractions. So whatever our number is, the root of our number, I can write it like this in the form of ab, where our a and b are prime. Let me write it. Let me tell you what are primes. A and b are prime. Whatever our a and b are, both are prime. Prime means that whatever our numbers a and b are, they do not have any other factor except 1. There is no number other than 1 that can divide both a and b. So what have we done here? We have kept square root 2 equal to ab and both a and b are prime. Now let us rearrange it. Let us make an equation. Our root 2 will go here. You can see how b is. If we shift it to this side, it will be in multiply with square root 2 and equal. You will be left with a here. Now what will we do here in the next step? Whatever our equation is, let's square it. Let's square this side as well. First, I will write in brackets, squaring both sides. Let's square both sides. So, I put brackets here and square this side as well. What value will we get after squaring? Whatever our root is, we will square it. The square of 1 will cancel out the value left. 2, after that. Whatever our this is b, then the value will be a. The square of our b is equal to u. Here, we have a. If we square it, then this will become the square of a. Whatever our equation is here. What conclusion do we draw from this? Understand carefully. Whatever our superscript 2 is, what can be its factors? By which number can a superscript 2 be decided? It's very simple. The factors of a superscript 2 will be on this side. Whatever numbers can divide a superscript 2, they will be on this side. Like here. You can divide a superscript 2 and here. There's b superscript 2. It can also divide a superscript 2. Which means that we can conclude that it is divisible by a superscript 2. So, I will write here that a superscript 2 is divisible by u. If you come on this side, then it will be divisible by a superscript 2. And one point is simple. If a superscript 2 is divisible by 2, so r will also be divisible by 2. So, here we will write it is also divisible by u and whatever bracket is there. We will close it. This is our conclusion number 1. Which means that this of ours is divisible by 2. It can be divided by 2. The factor of a will be 0. We have drawn this conclusion. First one. Now, the factor of a here is 0. So, it means, whatever our a is, I can write it in this form. Second, here, I can write it in this form. A equals 2c, which means if the factor of a is 0, then a equals 2 and c can be any one of our numbers. I will write c here. Any of our a is divisible by 2. It is divisible by 0. So, here a equals 0. C, I can write c in this form and c can be any of our values. Whatever our a is, it is divisible by 2. It is divisible by 0. So, here a equals 0. C, I can write it in this form and c can be any of our values. This is the same value. Let us put it in the first equation. So, on this side, whatever is the square of b, it will come today. This value of ours will come next. It will be given here. Here, the square of a is our value of a is 0. So, I will put it in place of a. Then, c and a are squared here. So, whatever is its value, it will also become square here. Now, be careful. See here, if we solve this, u are the square of b. Next, it is equal to u. In which case we will square u. It will become 4. After that, whatever is our c, if we square it will become the square of c. Now, here on this side, u are 4 on this side. This can be cancelled out from the table of u. 2 times 1 is equal to 2. 2 times 2 is equal to 4. What value will be left here? We have 1. If we multiply 1 by b superscript 2, then the square of b will become equal to u. Here, our u is. If we multiply it by c superscript 2, it will become the square of 2c. Now, the value that we have got. This is the equation. What conclusion can be drawn from here? Look, this is the square of b. What can be its factors? B superscript 2 can be divisible by which numbers? It can be divided by any number on this side. Here it is 0. That is, B superscript 2 can be 2 superscript 2. So, here this kink is there. But whatever comes out, I have to write that 20 times divisible by 0. B square can be divided by 0 because 0 is its factor. If B superscript 2 is divisible by 2, then B is also divisible by 0. B can also be divided by 0. This is our guess. Here is the second conclusion. What did we assume in the beginning? In the beginning, we assumed that a and b are prime. That is, they cannot be divided by any other number except 1. But if we look at the first equation and the second one, whatever conclusions we have drawn from the equation, a can be divided by 2. B can be divided by 2. If both the numbers are divisible by any other number except 1, then they are not coprime. Which means that we have made a wrong assumption that square root 2a/b is equal to 1. The common factor of a and b is also derived here. Apart from 1, a can be divided by 2. Here it can be divided by 2. So here I will write a and b having common factor 2. In the beginning, we had assumed that a and b are coprime to us. They do not have any other common factor except 1. But later we came to know that 2 and 2 are the common factor of both a and b. So whatever contradiction we get in this question, it is because of our wrong assumption. In the beginning, we had assumed that square root 2 is our rational number, which cannot be a rational number. So we will write it here due to contradiction. So this contradiction is because of our color. Whatever we did wrong in the beginning, because of that we get this contradiction in the question. I will explain the contradiction again. What is the contradiction? That a and b are prime numbers, which means that they have no other factor except 1. But we also get 1 as the factor of both. So this contradiction of ours happened today because of the fact that root 1 is a rational rational number. Now this root 1 is not a rational number. So definitely it will become an irrational number. In the end, we will write root 1. It is irrational. This has to be proved in this way. Such questions like square root 2, square root 3, square root 5, root 7. Whatever numbers are given like this, they have to be proved by this contradiction method only that they are irrational. It is a very simple method. If you practice it, then it will become very easy for you. So this was the last concept. With this last concept, the introduction to real numbers takes place. Complete. I hope you have understood all the concepts and formulas that were explained with examples.